Hi everyone. Thought I'd give a little training. Um, well, it's a three-page training info about ionizing radiation. I thought he'd get it. I thought everyone would get a kick out of it. So we'll give it a spiel here. Ionizing radiation. What is ionizing radiation? Introduction. Waves and particles. The purpose of this section is to provide information on the basics of ionizing radiation for everyone. Energy emitted from a source is generally referred to as radiation. Examples include heat or light from the sun, microwaves from an oven, X-rays from an X-ray tube, and gamma rays from a radioactive element. So, ionizing radiation with enough energy so that during an interaction with an atom, it can remove tightly bound electrons from the orbit of an atom, causing the atom to become charged or ionized. Here we are concerned with only one type of radiation, ionizing radiation, which occurs in two forms, waves or particles. Forms of electromagnetic radiation. These differ only in frequency and wavelength. Heat waves, radio waves, infrared light, visible light, ultraviolet light, X-rays, and gamma rays. Longer wavelengths, lower frequency waves, heat and radio, have less energy than shorter wavelengths, higher frequency waves, X and gamma rays. Not all electromagnetic EM radiation is ionizing. Only the high frequency portion of the electromagnetic spectrum, which includes X-rays and gamma rays, is ionizing. Waves. Waves, I guess we all have waves. Most of the more familiar types of electromagnetic radiation, e.g. visible light, radio waves, exhibit wave-like behavior in their interaction with matter, e.g. diffraction patterns, transmission, and detection of radio signals. The best way to think of electromagnetic radiation is a wave packet called a photon. Photons are chargeless bundles of energy that travel in a vacuum at the velocity of light, which is 300,000 kilometers a second, 168,000 miles an hour. Particulate, that's another form. Specific forms of ionization radiation, particulate radiation, consists of atomic or subatomic particles, electrons, protons, etc., which carry energy in the form of kinetic energy or mass in motion. Energy emitted from an atom or nucleus in the form of waves or particles. There we go. Electromagnetic radiation, in which energy is carried by oscillating electrical and magnetic fields traveling through space at the speed of light. Alpha particles and beta particles are considered directly ionizing because they carry a charge and can, therefore, interact directly with atomic electrons through Coulombic forces, i.e., like charges repel each other, opposite charges attract each other. The neutron is an indirectly ionizing particle. It is indirectly ionizing because it does not carry an electrical charge at all. Ionization is caused by charged particles, which are produced during collisions with atomic nuclei. The third type of ionizing radiation includes gamma and X-rays, which are electromagnetic, indirectly ionizing radiation. These are indirectly ionizing radiation, ionizing because they are electrically neutral, as are all electromagnetic radiations, and do not interact with atomic electrons through Coulombic forces. Isotopes and activity. Isotopes. Atoms in their normal state are electrically neutral because the total negative charge of the electrons outside the nucleus equals the total positive charge of the nucleus. Atoms with the same number of protons and different number of neutrons are called isotopes. An isotope may be defined as one or two or more forms of the same element having the same atomic number, Z, differing mass numbers, A, and the same chemical properties. These different forms of element may be stable or unstable radioactive. However, since they are forms of the same element, they possess identical chemical and biological properties. Hydrogen, tritium. The simplest atom in the hydrogen atom, the simplest atom is the hydrogen atom. It has one electron orbiting a nucleus on one proton. Any atom which has one proton in the nucleus is a hydrogen atom. Like both of the ones shown here, hydrogen 2 is called deuterium. Hydrogen 3 is called tritium. However, while their chemical properties are identical, their nuclear properties are quite different, as only tritium is radioactive. Activity. The activity of a radioisotope is simply a measure of how many atoms undergo radioactive decay per unit of time. The SI unit for measuring the rate of nuclear transformation is the Barriquel, BQ. The Barriquel is defined as 1 radioactive disintegration per second. The old unit for this is the Curie, the CI, in honor of Pierre and Marie Curie, who discovered radium and polonium. The Curie is based on the activity of 1 gram of radium-226, i.e. 3.7 times 1010 radioactive disintegrations per second. Dose and source. Only the amount of energy of any type of ionizing radiation that imparted to or absorbed by the human body can cause harm to health. To look at biological effects, we must estimate how much energy is deposited per unit mass of the part or whole of our body with which the radiation is interacting. The international SI unit of measure for absorbed dose is the Gray, which is defined as 1 joule of energy deposited in 1 gram of mass. The old unit of measure for this is the Rad, which stands for radiation absorbed dose. 1 Gray equals 100 Rad. Equivalent dose. The biological effect depends not only on the amount of absorbed dose, but also on the intensity of the ionization in the living cell caused by different type of radiations. Neutron, proton, and alpha radiation cause 5 to 20 times more harm than the same amount of the absorbed dose of beta or gamma radiation. Let me say that one again. Neutron, proton, and alpha radiation can cause 5 to 20 times more harm than the same amount of the absorbed dose of beta or gamma radiation. The unit of equivalent dose is the sievert. The old unit of measure is the rem. 1 sievert equals 100 rem. Sources of radiation exposure. Radiation is permanently present throughout the environment in the air, water, food, soil, and in all living organisms. Large portions of the average annual radiation dose received by people results from natural environmental sources. Each member of the world population is exposed on average to 2.4 millisievert years of ionizing radiation from natural sources. In some areas in different countries of the world, the natural radiation dose may be 5 to 10 times higher to a large number of people. But let's always remember that 2.4 millisievert year of ionizing radiations from radon natural sources, those are the ones that are lower in frequency. These natural sources aren't in the high frequency range into the gamma range that hurt us. So 2.4 millisieverts of ionizing radiation from natural sources does not hurt us because these aren't high frequency radiated waves at all. Only from radioactive material from man can kill biological beings such as animals, plants, microbes, phytoplankton. The list goes on what Fukushima is killing. I hope this helps with a little information on ionizing radiation, and I will try to get better at my videos. Take care, God bless. This ends this broadcast day.